Hello, my name is Faisal Waris, and this is a demo of an application called RT.Assistant. So RT.Assistant is an application, basically a chatbot or a voice chatbot to answer questions about phone plans. Now, first of all, this application has been written in a framework called Microsoft Maui, and that is a cross-platform application framework. So you can build native applications for iOS, Android, Mac OS, and also for Windows. So here you see three versions of the demo application. So this is the Mac OS version. This is the version for iOS, and this is the version for Android. If I click on the submit button here, you'll see that they are all live. Okay, let me do a quick demo of this application, but before that, let's take a look at how this application was put together. What are the main components? So we have Microsoft Maui as the framework for native mobile applications. Then this application, of course, integrates with the OpenAI real-time API for voice conversations. It uses an real-time multi-agent framework. And finally, the plan data is represented as Prolog facts, and Prolog querying is used to retrieve that information. Okay, now let's take a very quick look at the application. I'm going to connect to the OpenAI API. Hello, can you help me find a phone plan?
Of course, I'd be happy to help you find a phone plan. Could you tell me a bit about what you need? For example, how many lines do you need, how much data you typically use, and if there are any special features you're interested in, like
I'm
international.
looking for a plan that supports 4 lines for about $100.
All right, you'd like a plan that can cover 4 lines at around $100 per month. Let me check the available options that match that price point. Here are a few plans that match what you're looking for. The closest one is called Core 4 Line Offer, and it's exactly $100 per month for 4 lines. There's also a plan called Core that's about $105 per month. Then there are a couple of special category plans.
Okay, so that was a quick demo. Now I will switch to covering some of the components in more detail, and then we'll do a little bit more in-depth demo. So one question to ask here is, why do we need a system, a complex system to understand phone plans? Well, it turns out that phone plans are no longer simple products. They're actually bundled products and services. And these, so let's take a look at a typical plan. So you may have a base plan, which is the voice and data part, but then you can have several features on top. Mobile hotspot, what are the limits for the hotspot? Premium data, streaming services, taxes and fees may be included or not, internet on the plane, special discounts for the different groups. And on top of that, features may have additional conditions. So for example, Netflix may be included if you get 2 or more lines in a plan, but it's excluded if you only get 1 line. So you can think of this plan information as being fairly complex. In fact, you may think of them as a set of rules, and maybe you need a rules engine to to make sense of this data. This is where Prolog comes in. So Prolog is a logic programming language. You can express these types of complex rules in a very precise and non-ambiguous way. And that's why we need a system like this for consumers to be able to understand which plan works best for their needs. Okay, now let's talk a little bit about the multi-agent framework that underpins this application. So this framework is called RT Flow. It has three main components: the flow, which is an asynchronous state machine, the bus, and the agents. Um, the bus, of course, connects all the agents together and has a separate channel for the flow. The idea here is that uh, uh, if agents are relatively autonomous, then they can just communicate with each other over this broadcast channel that connects all of the agents. And the flow can be just a minimal way of controlling the overall system. However, there are situations where you want more control. So in that scenario, the agents will send their messages to the flow instead of sending it to each other directly or broadcasting that message on the agent channel. They will send that to the flow, and the flow, depending on which states it's in, will then orchestrate the agents accordingly. Now, if you look at topologies for multi-agent frameworks, there's this star topology and there's a bus topology. So star topology has a central sort of controlling software that orchestrates the agent. And in the bus topology, you have essentially a broadcast channel for the agents. So RT Flow is a hybrid of bus and star topologies. Okay, now let's take a look at this specific configuration of RT Flow for the RT Assistant sample application. So what are the agents and what are their functions? Well, let's start with the voice agent. So the voice agent's job is to maintain a connection with the real-time voice API through the WebRTC protocol. Now, when that connection is established, the WebRTC libraries under the covers wire the audio to the device hardware. So the audio is flowing directly from the device uh, components to the OpenAI real-time API model. But the data from that uh, connection is going to the voice agent. And in fact, there is a steady flow of messages coming from the OpenAI real-time API that the voice agent needs to handle. Um, there's the query agent. Query agent is a relatively simple agent. Its job is to run canned queries using the Prolog query engine. The CodeGen agent, so this agent is used to take a natural language query and convert that to Prolog using the LLM API, and then use the Prolog query engine to obtain the results. And the app agent simply listens on the bus and reports the events to the UI, as configured. Okay, now let's walk through a simple scenario to provide a sense of how the agents work together. So let's say the user asks a question about a phone plan, something like, can you find me a plan that supports 4 lines for $100 or something like that. That audio will be sent to the real-time API, which will convert that into a natural language query or phrase that into a natural language query, and then we'll send that over the data channel to the voice agent as a tool call. So the voice agent will then broadcast a message on the agent bus, which will be picked up by the CodeGen agent. So the CodeGen agent will then use the LLM to convert that natural language query into equivalent Prolog obtain the solution to that query, the solution set, and then broadcast that the solution set message on the channel, which will be picked up by the voice agent, and the results sent back as tool called results to the API, and the API will then take those results and announce them to the user via audio. Okay, let's do a quick demo of the application. I'm going to click this button to connect to the API. Hello, can you help me find a phone plan?
Of course, I'd be happy to help you find the perfect phone plan. To get
I'm
started,
looking for a plan that can support Netflix for 4 lines for about $200 per month.
I found two plans that match your needs. One, the Connect Plus plan. It costs $185 per month for 4 lines and includes Netflix Standard with ads. Two, the Connect Next First Responder plan. It costs exactly $200 per month for 4 lines and also includes Netflix Standard with ads. Would
Do
you like
any of these plans include taxes and fees in the prices?
Both of the plans we found include taxes and fees in the monthly price. Let me summarize the two options. One, the Connect Plus.
Okay, so that was the demo. I'll just quickly walk through what just happened. Okay, so I inquired about a plan that can support Netflix for 4 lines for about $200 per month. That audio was transmitted to the OpenAI API via the WebRTC channel. The API then rephrased that into an English language query that you see here and sent a tool call message to this application, which then converted this English language query to equivalent Prolog code with the help of an LLM. The Prolog code was executed using the Prolog engine, and these results were obtained that you see here. They were also sent back as the result of the tool call, and the API then responded with the audio, based on these results. Then I inquired about further. So I had another question about whether taxes and fees were included. Additional tool calls were made, and the results of those were also announced to me via audio. Okay, so let's take a quick look at the Prolog code itself. So there are two parts, the predicates and the query. So predicates, you can think of them as supporting functions or modules. If you have a complex query, typically you divide the query up into the query part and the predicates part. So intermediate processing is given to the predicates. The thing here is that in Prolog, if you have this name which starts with an uppercase letter, that is known as a free variable. So when you run the query and solutions are found, then these variables are bound to values from those solutions. So for example, for this particular query, we have two solutions, and you have the values of these variables being bound to the solution values. Now, the key thing is that if you want to control the output of the query, you have to worry about what free variables you have in the query, because that's what you will see in the output. If you have too many free variables, then the output will be larger, and it's not really ideal for LLMs because you're bloating the context. So you want to keep the intermediate free variables in the predicates and only use the free variables you need as part of the output in the query. In this video, we looked at an application called rt.assistant, which is a sample application for question answering over phone plan information. where the phone plan information is represented as a set of Prolog facts and rules. This application is built with a framework called Microsoft Maui, which is a way of building cross-platform native mobile applications. We also looked at RTFlow, a real-time multi-agent framework where several agents collaborate with each other in service of the voice bot. We also looked at connectivity to the real-time OpenAI real-time API via WebRTC that's implemented by a library called RT OpenAI. And finally, we got a glimpse of how natural language queries are converted into equivalent Prolog with the help of an LLM to generate responses to user queries. This video is at a high level. There's another accompanying video that dives deeper into code.